This concludes our lessons on network technology and security. As you recall, we reviewed the OSI model, the TCP/IP suite of protocols. We looked at network transmission media and transmission technologies. We looked at network infrastructure components, including the personal area networks, local area networks, metropolitan area networks, wide area networks, and then some. We looked at wireless networking technologies, and then we looked at attacks on networks. If you want to dig deeper into these topics, here are some internet-based resources that you can use to study these topics a little further. Feel free to pause the presentation if you're going to go explore some of these or you want to write some of these URLs down. In order to qualify how well you've learned from these series of lessons, please answer these following questions. The answers are presented on the next slide, so again, what I ask you to do is just pause the video at this point and answer these questions, and then proceed to the next slide for the answers. So here are the answers for the preceding questions. The types of media that is used for networks from weakest emanation security to strongest emanation security are wireless, unshielded twisted pair, shielded twisted pair, coax, and then finally fiber optics being the most secure. Remember, fiber optics use photons, not electrons, and photons don't emanate, whereas electrons do. The other technologies use electron flow and therefore have some level of emanations, resulting in emanation security threats. The second question deals with the 4 different types of transmissions on a network. We have unicast, that's one-to-one. We have multicast, that's one-to-many. Remember, the multicast, they have to opt in to the multicast transmission from one source to many clients, and it uses the Internet Group Management Protocol. We have a broadcast, that is from one to all the nodes within a certain range. And what is that range? Well, it's defined by the broadcast domain. Typically, the router is the boundary for the broadcast domain, and bridges and switches forward all broadcasts. And then the last one is one that hasn't really gotten much use yet, but we might see it happening more and more as we evolve into IP version 6, and that's called the Anycast. Now, the Anycast is where I would assign a single IP address, the same IP address, to all the nodes that provide this one service. For example, all my DNS servers will have the IP address 10.10.10.1. And now we'll configure all the clients to go to 10.10.10.1 for DNS resolution. This is a one-to-one of many, because I can assign this same DNS IP address to many DNS servers, and you will send your query to that one IP address, but the nearest DNS server to you will be the one that your transmission is sent to, and you will receive the response back from. So this is one-to-one of many, the Anycast. The next one deals with firewalls. What are the 5 generations of firewalls? The first one was the packet filtering firewall. This was a router that had an application added to it that did filtering based on IP addresses and on port numbers. Now, this is a layer 3 device, and it was either wide open or all the way closed. There was no middle ground. There were no conditions other than red light or green light for that IP address and port combination. Second generation was called the proxy firewall. We had a circuit level and an application layer proxy firewall. This guy broke the connection between the client and the server. To the client, the proxy firewall resembled the entire internet. And to the internet, the proxy firewall represented all the clients that proxy server was responsible for. It could include user authentication, group authentication, all the services of the packet filtering firewall. It could do deep inspection if we were application layer and actually rebuild the content and provide content filtering, etc., etc. So the proxy firewall was very intelligent, but also very slow. Third generation was the stateful firewall. This said that all inbound requests are denied, except those inbound requests that I can find a stateful request that we submitted prior. So all inbound responses will only be allowed through if we asked for it. Anything unsolicited, deny. So this was our third generation. Now, the fourth generation packet filtering firewall is the combination of the stateful firewall and the packet filtering firewall. And this is really what a firewall needs to be at its minimum. We might add some of the intelligence of the proxy firewall on top of this. But basically, the dynamic packet filtering firewall, 4th generation firewall, virtually all of our firewalls today are that type of firewall and may include proxy capabilities as well. The 5th generation firewall was the kernel proxy. This guy doesn't exactly exist today. The kernel proxy, the notion was that if we could put this application that did the filtering, that is in essence the firewall, if we could put that software in the kernel of the appliance, then it must be faster and stronger. The kicker, though, was now you've got all that dirty stuff coming back off the internet, all that dangerous malware and stuff coming back in that I have to bring down into the kernel and examine it before I can make a decision on it. This is too much dangerous stuff, too close to the heart of the device. And so the conclusion was this wasn't terribly safe or smart. So they pushed the bulk of this back up into the user mode and away from the kernel mode. And now I have an extra layer of security between that dangerous stuff that I'm filtering and the actual kernel of the operating system for the appliance. So the kernel proxy doesn't exactly exist today in that true original form. There might be some components of the firewall that live in the kernel, but the bulk of it is back up in user mode, not down in the kernel mode of the device. Question 4 dealt with secure channels or VPNs, and we have the secure shell, the point-to-point tunneling protocol, IP security. Remember, IP version 4 does not have any native security built into it. And when they realized there's a need for security at layer 3, they had to invent a new protocol called IPsec to implement that authentication, integrity validation, and security encryption for IP traffic. We have layer 2 tunneling protocol. This guy does not provide any form of encryption, but does encapsulate whatever you're transmitting in a layer 2 frame. So it is usable over all layer 2 wide area networks like ATM, frame relay, X.25. The next one is a very heavily used protocol today on the internet. It's a pretty good protocol, still quite strong and evolving. And this is secure sockets layer and transport layer security, SSL and TLS. The latest version of SSL is transport layer security. They were slightly different in the early days, but the new version of SSL is TLS. We have SSTP, that's the Secure Sockets Transport Protocol. This is a VPN technology using SSL. And finally, question 5 dealt with wireless security. The original wireless security implemented in 802.11 was called WEP, Wired Equivalent Privacy. And then when they realized how flawed WEP was, they chartered a new task group and came up with 802.11i that included Wi-Fi protected access, a short-term transitionary security improvement over WEP, and the eventual, this is where we need to be today, WPA2, Wi-Fi protected access version 2. Now that is also called the Robust Secure Network, or RSN. And this completes our course on network technology and security.